Hey, boys and girls. We are here to talk about a particular dark Nephilim encounter. No, Scott.
Hey.
Hey. Okay. With Andrew. Hi, Andrew.
Hello.
Andrew's in charge.
Okay. So I guess do I just go from here?
Yeah. Just go ahead and tell us what happened to you. Where did he touch you on the doll?
Oh, well, I wouldn't say that, but
Okay.
well, I would. So I guess the claim that I wanted to go over was, and I've seen him make this claim repeatedly, even though I know for a fact that he doesn't understand the statistical nature of entropy. Because like I gave an example to him once, and he identified the answer of which was lower entropy that was contrary to the actual real life situation. For anyone curious, it was a glass of ice and a glass of water, or a liquid water. But anyways, off topic. What I wanted to go over was this claim that he made that if indeed the universe is eternal, which no one's saying it is, it's just speculation at this point. But like, for instance, if the universe did exist for an infinite amount of time prior to the Big Bang state, the amount of usable energy would be all exhausted, basically, according to him, or from what he said, I'm presuming he meant like infinitely exhausted, like all dispersed and everything. And for one, that kind of struck me as kind of assuming that the conditions of today's, not today's universe, but like the state of the universe today is how it always was, which of course we know for a fact is not the case. Like even going back fractions of a second after the Big Bang state, like you can see that the laws of physics themselves had not fully, I guess, separated, if that makes sense. Like the fundamental forces of nature were still unified and began to split off of one another. So we know the physics then, and we go back so far, and we know the physics then was quite different than it is today, and we go back so far, and the physics doesn't make sense at that point, up to a certain point, and that's what we call the Big Bang singularity or time zero. And so that's the limit of our understanding. So for one, and I'd like to hear your guys' thoughts on this. For one, assuming that the current conditions, the current physics of the universe, including entropy, applies prior to that period of time, doesn't really make sense to me. But what do you guys think?
Well, the whole thing, and Leo put it well a few days ago, or maybe last week. Asking what happened before the Big Bang is like asking what's north of the North Pole. For one thing, so what we're really asking is what is the nature of the universe around our or what is the nature of the cosmos around our universe? Or is that, I mean, that may not even make any sense because the geometry may be totally different, right? So we're no longer talking about space-time. We're talking about something different, right? And so there is no before the Big Bang. And and even to talk about an infinite amount of time prior to that, where things are causally happening, I don't think that makes any sense. And I think we just don't know, because it is so bizarre that you can't even begin. I mean, it's difficult for our language to even address the problem, let alone know what it is. If we do find something out, it is going to be mathematical in nature. There's going to be some math structure that tells us how space-time itself expanded or came out of a singularity, and who knows what that is.
Yeah, so, I think that's the common response is what happened before the Big Bang is like asking what's north of the North Pole. And like you said,
we're trying. Both of us hit him at the same time.
That's right.
I was glad you keep coming here. We need some help on this.
Yeah, so
can you hear us?
Leo.
I can hear you.
Leo, are you here?
Yeah, I'm right here. Can you not see me?
Okay, but you don't have your mic down, so we can't hear you.
That's weird. In Google Meet, I can have that up and people hear me clearly. It's strange that how it differs from platform to platform.
That is strange.
So, yeah, if you put it down on Google Meet, does it get like super loud then?
I don't think so.
Oh, okay.
I think just it's the way that the platform picks up audio. It's different. Like on Discord, like if I go to take a piss on like Discord, the sound will not pick up. On StreamYard, it won't pick up that sound even with this down, but in Google Meet it will. So I have to mute in Google Meet if I go in the bathroom to take a piss.
They probably
I've always said piss on Discord. Just piss on them.
They probably have an automatic equalization or something like that, where they automatically try to equalize sound, which I wish they had on StreamYard, because I keep having to adjust people's volume up and down to match everybody else. So anyway, okay, so go ahead, Andrew. Andrew, Nephilim's theory of the infinite universe.
Okay, or I guess if you want, Leo, I can relay the topic today, because I feel like you're probably gonna have a better understanding of what the flaws are in this argument. But basically, Neph was claiming the other day that if indeed hypothetically in the future we find, okay, before the state that we call time zero, there was an eternal past before then, if before makes sense, like I said, that entropy would prohibit that, because the amount of usable energy in the universe today would therefore be infinitely dispersed and diluted, basically. So I guess, what are your initial thoughts on that claim?
Wait, so this is what Nephi is saying?
Yeah,
he's saying that there can't be a before the universe because then entropy would be infinite?
We'd run out of energy, yeah.
He's saying if the universe was infinite in the past, then today all the energy would be infinitely exhausted.
Oh yeah, it's the same argument that William made, that the second law of thermodynamics tells us that the universe is winding down, and so you can't go infinitely into the past, all while overlooking the fact that physics is fundamentally different when we go back to the early universe, and thermodynamics is probably emergent anyway from deeper, more underlying quantum mechanical properties or states, and so we don't really know how thermodynamics behaves at the earliest moments of the universe, and the four laws of thermodynamics as we understand them now could be entirely different. It might not even be applicable at all in the early universe, and that's the problem. This is how you know if somebody has absolutely no understanding of cosmology. If they assume that the physics that govern our reality as we see them today apply in the exact same manner in the earliest moments of the universe, just give up, because you do not understand the physics. You just don't.
Right, because if entropy is statistical in nature, and doesn't that mean that it's an application of quantum mechanics, basically? So that, or I guess like an offshoot of it, basically. So that means since we don't have a quantum theory of gravity, then we don't really have a quantum gravity fear of entropy, I guess is what I'm saying.
Yeah, well, entropy isn't really, I mean, there's an entirely new emerging field in theoretical physics called quantum thermodynamics, which is trying to understand the nature of thermodynamics at the quantum level of reality. I still take the idea, and I think a lot of theoretical physicists do as well, that the concept of decoherence likely has something to do with what entropy is, whether fully or partially, don't really know yet, but decoherence,
Hello.
just if you think about what decoherence is, it seems to be almost intrinsically tied to entropy.
Right. Okay. Yeah, I'd have to look into that because I've just learned what decoherence is. But anyways,
Well, that's just patently false, Leo.
Sure, if you're Nephilim free and you don't understand physics.
Or Maddox.
Hmm.
Well, Maddox knows more than Nephilim free, even if only a very small amount.
Wow, that is not by
Thanks.
much. That is not a. That is not
Nephilim described this on the stream as a scientific fact, I think, or something he was saying. So this is a
or like
scientific.
well, the second law is a fact by all intents and
I
purposes
mean,
of the word fact, but like
yeah, the only
how it applies then.
the only scientific fact Nephilim free knows is that he's a drunk. Too far? Sorry.
He was
Maybe.
sober last night. I want to hand it to him. His speech was a lot clearer last night. He was not slurring.
Where was he at last night?
He did a stream on his channel, an after show thing for that debate, I think. So he was alive last night.
I did like some very, very low level, very minor trolling in Sal's side chat.
Oh, did you?
Oh, did you?
Oh, I saw
Trolling,
you
it was
there.
trolling. So it was trolling so subtle, most people probably wouldn't have been able to recognize it as trolling, but
Yeah.
still fine. Sal
So-
seems to think that Big Bang cosmology is completely falling apart, and my question is, if it is, how come like no cosmologists are talking about this?
Yeah.
I mean, when there are paradigm shifts in physics, it's not like just covered up or hidden. It's talked about. Look at what happened when we discovered the Higgs boson. Look at what's happening now with the muon G-2 experiment. I mean, when there's paradigm shifts or potential paradigm shifts coming up in physics, the physicists can't shut up about it. If the Big Bang model were somehow failing or were just falling apart, you would be hearing about it all over, and you don't. Now, I know what Sal's response would be is, oh, well, they don't want everybody to know that, their religion of the Big Bang is falling apart, so they swept it under the rug and turned a blind eye. But that we already know that's false. That's just not how scientists look at science. They don't try to hide it and cover it up. The people that do that are people who aren't really scientists, but want to manufacture data. But actual scientists don't do that.
Who
Right,
was it?
no,
Who
no.
was a guy on the on their channel saying that redshift has been overturned as a proof or evidence for the expansion of the universe. Somebody was trying to say, oh, like there were multiple phases of redshift or something like that. I don't know.
That makes no sense.
Yeah.
Well, wait, multiple phases of redshift. What does that even mean?
I can't repeat what he was saying. But
I know.
yeah,
I'm
know if
just
it was
saying, what does that
Sal.
even mean?
Yeah, I don't know if
Well, Leo.
Sal or SFT or one of those two dudes had somebody on that was
Jay
trying to do this.
Jay did have a question. I heard Argatha say something about Big Bang
I
having
saw
a
that.
problem with heat being evenly distributed across the universe. What the hell is he talking about? If I had to guess, I would assume he is probably referencing the horizon problem, which is
Yeah,
solved
sounds
by
about right.
inflation.
Well, I have
And
a quick
it
question.
asked, I mean, if the scale of the universe is larger than the amount of time it would take for electromagnetic radiation to traverse that distance, then why is the universe electromagnetically fairly homogeneous, with the cosmic microwave background and everything? Because inflation stretched those previously really, really close together parts of the universe really, really, really far apart. And then they gained a local equilibrium all over, which now looks like universal equilibrium in the CMB.
Okay, I have a quick question for you, Leo. You mentioned muon G2.
Muon?
Muon,
G
sorry.
minus 2?
Yeah, G-2. Now, I was watching that PBS, PBS video, but I didn't get a chance to finish it. Would you mind, would you mind talking about how that's a big deal for
It's
science?
just new physics. Why is the muon wobbling? Why does its magnetic dipole moment wobble?
New physics as opposed to old physics.
So is it
Or
like
an
an
extension.
anomaly, or is? Oh, sorry.
Yes, it's an anomaly. We don't know why the muon's magnetic dipole moment wobbles. Could be new physics. Could be a statistical fluke. We don't know. I'm not getting excited about it because physicists are supposed to be quite pessimistic because it's almost always a statistical fluke, not, novel physics.
Yeah, because wasn't they had a lower sigma number than they really needed?
Sigma 4.2, they need sigma 5.
Okay.
Well, let's just hope that future experiments hold up, and and we're ever on the precipice of a new physics, or I should say, a greater understanding of the physics we already know.
I think that if it is new physics, and I think that it's probably not, it's not a new force because we've pretty much ruled out the existence of new forces, at least to a reliable degree.
What about dark photons?
I never heard of them.
Well, you really should look into that because I've looked into I've read some of them. I read a little bit on it like a while ago, and the existence of dark photon may suggest the existence of a dark electromagnetism, which may which may suggest there's a fifth force, and if there's a fifth, there may be a. You get the point.
Well, I would say a dark photon is the most useless photon I could imagine.
I mean, no.
Well, you can't see anything with them.
I mean, just because we can't see anything with it doesn't mean it doesn't have its uses within nature.
That'd
And
be
besides,
cool. Dark photon and flashlight.
yeah, and besides, and this is just speculation, the dark photon could just be merely a shadow of a regular photon.
Leo's cringing.
I'm assuming you mean shadow in some non-standard sense because
It's like it's. I don't know. All right, I'm just being a scientist here.
Or like the opposite, like there's an electron and a positron.
Yeah, like a shadow.
The photon is its own antiparticle, as is, I believe, the gluon. I might be wrong about that. Well, actually, I think I am because gluons carry color charge, whereas photons do not carry electric charge.
Well, regardless, if you're interested in
it, I did just check it out quick on Wikipedia. The part that bothers me is it says it's in a minimal scenario, this new force can be introduced by extending the gauge group of the standard model of particle physics with the new abelian U1 gauge symmetry. I don't think we work with any abelian gauge symmetries currently. I think there's a lot of problems with them, if I remember correctly. Most of them are non-abelian symmetries. So I'm sure that you can fiddle with the mathematics enough to get it to work, but that doesn't mean that's how reality actually is.
Well, Leo, try to keep it up in mind about the dark.
Well, I mean, I do. Right? I'm going to assume everything is false until there's good evidence to indicate that it's not, because that's generally how most physicists look at the world. Simply because of if new particles and forces were out there, we would have the most likely scenario is we would have seen some sort of implication of that by now, especially given the energy levels that we've examined. It's either, if there are new particles and forces out there, they're either so short-lived that they have absolutely no effect on our reality, and so might as well just assume they don't exist, or they are very long-lived but are so weakly interacting that they have absolutely no physical effect on our reality, and so we might as well just assume they don't exist. In short, if new forces or particles exist, then they exist in such a way that they appear to not exist at all, so we might as well just assume they don't exist.
Well, that's for me. I'm a proponent of the multiverse, even though who knows whether it exists or not. It's an interesting thing. Like for me, I've always thought that there's a multiverse. The various universes interact in ways that they overlap with each other. It kind of you know what I mean? It's kind of interesting to think about, but I don't know.
I've thought the multiverse is interesting. I just think that when one considers Occam's razor, it's entirely unnecessary. It doesn't add any extra explicative capabilities or predictive capabilities of our model that are at least currently useful in any way, shape, or form. And this is why physicists, I recently, let me see if I can't find it here on Twitter. I recently, like a couple days ago, if this stupid dumb fucking phone would ever actually read my goddamn fingerprint because they can't make sensors worth a shit anyway. It was by Sabina Hassenfelder.
Yeah, I know. I saw
And
that. I saw that.
What she worded was just absolutely beautiful. The way that
I
she
know.
said
I
it.
saw the thread.
Yeah, I don't think anybody else in here. I don't know how many people in here, other people in here, have Twitter.
Oh, I don't.
Right here. So it's a thread, but it's not super long. So just give me a second here.
Can you post
People,
it in
as
thread?
I have no, because I'm on my phone. People, as I have said many times before, if string theory were actually really simpler than the standard model, then physicists would actually use it to make predictions for the LHC. They don't. Why? Because it's useless. It's the same with supersymmetry. People who work on it claim it solves problems and it improves the standard model, but no one who actually makes predictions for the standard model expectations uses supersymmetry. Why? Because it's useless. Same with the multiverse. Supposedly it simplifies something, but no one who makes predictions for structure formation or the CMB starts with the probability distribution over the multiverse. They just use the concordance model. Why? Because the multiverse is useless. The same goes for literally hundreds of additional fields and particles and stories for the beginning of the universe. They're useless. They don't explain anything we observe. The bottom line is this. Look at what scientists do, not at what they say. If a hypothesis is really a good explanation, they will use it. String theory doesn't explain the standard model. Supersymmetry doesn't explain the Higgs mass, and the multiverse explains nothing. End rant. And that's it's a little blunt, but I think it's just blunt enough. These models aren't used straightforwardly because they're useless. They don't add anything to our models. They don't help us understand our reality any better. Yes, you can fiddle with the math to use these models to get the same reality we observe, but that doesn't make those models correct. It just means that there's some way in which you can tweak them to reproduce the universe that we observe. But if you really want a model to supersede a model that we're currently using, it has to do more than just reproduce what we currently observe. It has to make predictions for other things that we haven't yet observed, but maybe should. These models don't do that. They're just useless.
Can
I mean,
oh,
no, go ahead. I was just gonna disagree, kind of. Oh, go ahead.
oh no, you go ahead first. It's okay.
No, like it's I get the point she's making, but at the same time, it just seems not shallow.
Dismissive?
Yes, go ahead,
Well,
Andrew.
it's dismissed for the same reason that geneticists don't use genetic entropy when they're running models on, populations and things like that. Why? Because genetic entropy is useless. They don't utilize the idea of created heterozygosity. Why? Because it's useless.
Yeah,
it doesn't explain anything. It makes no predictions. It doesn't take our models beyond what they already have the capability of doing. It's useless. It's just useless math, useless science. Yeah, people might argue that's close-minded. I would argue it's not close-minded for the same reason that we don't use a flat Earth model. It's not that it's close-minded. The model is useless. It does nothing for us.
Leo, there's a difference between. Never mind, Andrew. You go.
Well, I'm not disagreeing with you, Leo. I would just say a caveat would be it's useless now, but there's always the hypothetical chance it could be useful in the future, right?
Oh, I mean, yes, but the less useful it is now, the less likely it is to be useful in the future.
Right. I would agree with that. Yeah. I would also say, like, or a question I might ask would be, is there any way that distinguishes, say, like the multiverse and cosmic inflation? See, they're not on the same ground, but they seem roughly on the same ground, predictive power wise. Am I wrong on that?
Yes and no. What I would say is that inflationary theory makes predictions, and we observe pretty much all of the predictions it makes about the large scale structure of our universe. The thing with inflation is you can modify the mathematics in a reasonable manner so that it is sort of an eternal inflationary model, but that isn't necessitated by or directly implicated in the math of inflation. So you can have an eternal inflation model where there are other universes that still gives the same predictions that we see in our universe, but that doesn't mean that the multiverse or that inflation truly is eternal. For the same reason that we can utilize in special relativity the anisotropic synchrony convention, and we can get the same universe we see now. It's just not useful to use it. It's not about what models that we can utilize to reproduce the universe we see and all the different ways we could tweak them to reproduce the universe that we see. It's about what works the best in explaining what we see and making predictions. That which works the best is what's going to be used. If it's not being used, it's probably because it doesn't do the best for us.
Like, or would a potential counterexample be like Newtonian laws of motion, for instance?
Well, but those are useful. We use those all the time. Granted, we only use them at a particular scale, but they're still useful. Whereas supersymmetry is useful nowhere. The multiverse is useful nowhere. They're just string theory is useful nowhere. Newtonian mechanics still has some use.
Okay. Yeah, I was also, if everyone's okay with it, can I ask an unrelated question that's kind of related to the original topic? Is everyone okay with that?
I mean, sure. Go ahead, Andrew. Like,
yeah, you don't
ahead.
have to ask, buddy. Just ask
Absolutely.
questions.
Yeah,
That's what we're all here for.
Okay with
no,
it.
hold on. I know, like on a side note, well, actually, no, never mind. You go. We'll talk about it later
Okay.
because there's something I want to talk to you about.
Sure. Okay. So Leo, so we were talking about entropy. Do you by any chance know anything that I don't about entropy density? What that means?
No, I've heard the term, but I couldn't tell you anything about what it means.
Darn. Oh well.
Yeah, let me give it a good Google search because I actually, now that you bring it up,
I found something on Ethan Siegel's blog, but some of it was a bit confusing to me.
I'm muted. What was the question, Andrew?
Oh, I'm just asking Leo about what entropy density.
Oh, okay. I'm pretty sure I already know the answer to this question, but just might sound like I might end up trying to condescend to you, but it's just genuine. You're quite familiar with single variable calculus, correct? Like the concept of a derivative, the concept of differentiation, integration, things like that.
Yeah, basically,
Okay.
yeah.
So, and this is from. Let me click on the link to get the website because I don't know. It's some like notes from some university or something like that. It doesn't really give me, but the entropy density S of T is the derivative of the Helmholtz free energy with respect to temperature. So the entropy density is just the negative of the derivative of that Helmholtz free energy function with respect to time. For I think is that partial derivative? Because those would be for two different variables, then wouldn't they? N and V. So I'm assuming it's a partial derivative.
Okay. Sorry to interrupt you, but I'm gonna go for a bit to talk to a friend of mine. Figured I'd let you know without leaving rudely. All right.
Oh,
It's all good.
see you in a minute.
Come back if we're still going.
Yep.
Yeah. Here, let me share my screen. I don't know if it'll
Because
add
Ethan
anything.
Siegel, Ethan Siegel explained it as the amount of entropy per unit volume, like the entropy of the observable universe divided by the volume of the observable universe, if I remember correctly.
Yeah, that makes sense. How much entropy is contained, or you could say more. I would think something along a more accurate way to word would be the rate of entropy for a given volume of some thermodynamic system. And that if you calculate the rate of entropy in that volume, you would have the density of entropy in that defined region. That makes sense. I am sharing my screen. I don't know if Speed is away from AFK at the moment.
I'm here.
But this gives, it's really the first two sentences and then the first two equations there that, let me see if I can. What do I do to zoom? Is it command scroll on a Mac, Speed?
Command plus.
So wait, let me see if,
Command-
command scroll doesn't do anything. I have to do
Command plus.
There we go.
Leo. Yeah.
Oh, S of T is the function defining your entropy density. So S would be the entropy density. T is the temperature. So it's the density with respect to temperature, it looks like. Or they say that the Helmholtz free energy. I do not know what that means with respect to temperature. And obviously here's the derivative notation for that, not difficult. The Helmholtz free energy density itself can be expressed in terms of an integral over the density of states. T equals Boltzmann constant by temperature, the integral over all density.
Where did you find this?
Lateral logarithm. I just Googled entropy density, and it was the first thing that popped up. 1 minus dx negative h bar by, oh god, is that omega? Is that lowercase omega? I think it is. Negative h bar. Isn't that lowercase? Hold on.
Wouldn't it be cool if our viewers could look at it too?
Wait, do I need to scroll down more?
No, I mean, wouldn't it be cool if our viewers had the link?
Oh, well then, yeah. You could have just said, "Hey, post a link in the YouTube chat."
I could have. I'm just trying to be
there
a
we
dick.
go. Yeah, I know. You're being speed. Yeah, that's negative h bar. I think that's omega. Negative h bar omega upon Boltzmann's constant by temperature. By the derivative, I think I'm almost positive it's lowercase omega, but I might be wrong on that. And obviously, h bar is reduced Planck's constant. So the Helmholtz free energy density must be the density over various states, thermodynamic states. This seems to be what is being expressed here. I can't highlight the equation. I can only move it, apparently. Phonons. Okay. Is this apply, or is that just the example that's being given? The frequency omega.
Sorry, I was answering a text.
That's fine. So we'll just discuss.
If I may clarify why I was asking about entropy density, because I was looking into this claim that Neph was making, and I actually asked a professor via email about it, and one of the things he said was that in terms of the entire universe, paraphrasing obviously, but like the entropy is a difficult topic for the whole universe. And instead of total entropy, it's better to think of entropy density.
Yeah.
So I guess I'm trying to understand what he meant by that.
I mean, I get what he means. I just don't know if I have the capability to really put it in words.
Okay.
I'm trying to find an analogy.
Okay. While you're doing that, I'm going to answer.
And this is probably going to be a bit contrived, but I would argue it still makes the point. Imagine a whole room. It's like saying that it wouldn't necessarily make sense to speak of the temperature of the room. It would make sense to speak of the density of temperature over the area of the room, if you understand that. Hopefully that's not a poor analogy. I feel like it might be, kind of.
I vaguely understand it.
Because when we start throwing this word density into things, like, for me, it clicks in my mind, but then I try to think, okay, how do I explain that to somebody else? And it's problems like this when people say, oh, well, if you can't explain it to a 5-year-old or a 5th grader or whatever they say, then you don't understand it well enough yourself. I'm sorry, that's just not true. That's just not at all true.
Well, since we're probably gonna need to, I seem to be stuttering now. Since we probably need to research it a bit more. I did have another topic I want to talk to you about, Leo. And it's this claim, probably a lot of creationists make, but like this claim that that star formation is impossible. And one of the things they mention, for instance, is the fact that gases heat up when they expand, and for some reason that prevents the stars from collapsing, I guess.
Yeah, and that's Now, they don't understand anything about gravity, which resists that force. This is why stars are a sphere. You have some force pushing outward equally upon every surface of that object, and another force, gravity, pushing inward equally on every force. Well, this has to do with I don't think it's surface tension. It's something that the surface area of a sphere has the lowest volume for the differences between those pressures or those forces, and so the object forms a sphere. It's generally referred to as hydrostatic equilibrium between those two forces, and that's why stars and planets and all this stuff are spheres. So that would just be complete. They would just be completely ignoring the effects that gravity would have on stars.
Right. Well, like I was looking into it, and it's actually pretty interesting how apparently dust plays a role in helping stars form, because it helps them radiate heat away so that it can collapse, I guess, if that makes sense.
Wait, what was that again?
So the clouds that the molecular clouds that form the star forming regions, they contain gas, but obviously they also contain dust particles and smaller molecules, like I believe one is like carbon monoxide, if I'm remembering correctly.
Some of them can contain larger molecules.
Yeah, and they help. They're good at help radiating away heat. Or infrared radiation, and that helps the cloud kind of collapse even faster, because infrared radiation can escape more easily than visible light, for instance, and that's how we see star forming regions.
If you want stars to form, you need a lot of very dense, very cold clouds of gas and dust. So obviously heat makes them not cold. The clouds will start to expand into the energy in between them, and you're not going to get regions that collapse into stars. And the more of the dust that exists in galaxies can scatter the infrared radiation, reducing its intensity, overall cooling the cloud down so that star formation can still occur.
Right. And the person I talked to about this also said that the fact that this dust, these metals in astronomical terms.
And just really, really quickly, in astronomy and astrophysics, a metal is any element heavier than hydrogen and helium.
Right. Yeah, for the audience, basically. So what they were saying was the fact that these metals didn't exist right after the dark ages of not of the Big Bang, but like the dark ages after the Big Bang, after the dark ages, the first stars that were forming were composed of only hydrogen and helium, and the fact that there weren't any metals around heavier than them kind of made it easier for them to collapse if they were larger, I guess. I'm probably phrasing that poorly. Is there maybe a better way to put it? Like,
I don't think that was a terrible way of wording it.
Because like the metals, the molecules help cool the cloud down.
And that keeps the cloud, because you have to remember, gases can behave very differently. Generally, they expand, they cool. That's how a refrigerator works. But that's if you just take gases and expand them. I mean, if you're expanding them because you're adding heat into the system and that thermal energy is exciting the system and driving some expansion, then obviously, it's not going to cool down, is it? So, I mean, yeah.
Right, the way I understand it is basically, okay, you don't have these metals, so you can't cool the system down, which means that the cloud is gonna be larger before it stops collapsing. And in order for it to be larger and stop collapsing, but still initiate nuclear fusion, it needs to have a lot of mass, and that means the star is going to be very massive.
Yeah, stars are going to be quite massive. They need in order to create the internal pressures capable of, like you said, initiating thermonuclear fusion.
Right.
That's why the sun is actually not a very large star at all. If you could rank stars from 1 to 7, with 7 being the largest, the sun would be a 3. The sun is really not that big, and it's still 1.3 million times the size of the Earth. So it's 99.4, 99.4, 99.6. It's about 99% of all the mass in the solar system is the sun. So
right, it's almost like this might be a bad joke, but like a deity decide, okay, I'm gonna put a big star here, and then I'm just gonna sprinkle some crumbs over here, and those are gonna be where life develops.
Yep.
Sorry, that's that. Was that too mockered?
No. I just the whole idea that humans in some way, shape, or form are favored or preferred in this reality baffles me. I'm sorry, we're just not. Like, if you want to believe that we are, cool, but we're not.
Okay. Since we're on the topic of astronomy, sorry, I'm putting out lots of claims today, but basically you've probably heard this one too, Leo. That dark matter and dark energy are fudge factors in the concordance
Yes.
model.
Oh, yeah.
Would you like to tackle that for the viewers?
Yes, I will. And then after that, I do have to head over to a buddy's house. He does need a little help. But
Okay.
so the thing is, it is true that we don't know the nature of what dark matter and dark energy are. We don't know their structure. We don't fully understand their function. That being said, we do know that they are there because galaxies rotate they rotate as if they contain more mass than what we can measure in a galaxy.
Right.
So there needs to be something that accounts for that extra mass that gives rise to the way in which we observe galaxies rotate, that their outsides rotate at the same speeds as the inside do, and it should be slower. That's
right.
We don't observing them.
The mass we measure based on the starlight, for instance.
Yeah. So the thing that we've decided, we've given a name to whatever it is that's there that accounts for that extra mass, whether that is that it is actually a physical particle or maybe just a modification of physics on a larger scale, whichever one it may be, whatever that anomaly is that explains or gives rise to that extra mass that causes the observations we see in galaxies and how they rotate is what we call dark matter. So we know that it's there. We just don't really know a whole lot about what it is, but we know that it's there.
Right.
Same with dark energy. Dark energy, the expansion of space-time is accelerating. So, and for immutable, that's what the cosmological constant represents. I think it represents, I want to say it has something to do with the density of space-time or the density of the field, because it's generally taken that the vacuum state of space-time, the vacuum energy is what dark energy is, so that hasn't been confirmed. That does seem to fit our observations, but we know that the expansion of space-time is accelerating. We know that some form of energy is going to have to contribute to that. Whatever that energy may be, we have decided to call it dark energy. The reason we're using the word dark in these instances is because, albeit we know that it's there, we don't really know what it is or how it works. It's dark to us, despite the fact that we know that it's there.
Right, and we also don't see it, so it's dark.
Mm-hmm.
Or not see it visually, I guess, is what I should clarify.
You can't detect it through electromagnetic radiation,
right.
Which is
yes.
why we're struggling to figure out what dark matter is. I am of the belief that dark matter is probably a physical particle that is very low mass. I tend toward axions as a form of potentially a very low mass lepton. Or wait, no, I think the axion would be more bosonic, wouldn't it? I think so.
I have no idea.
If I remember correctly, I think so. But yeah, that's really what dark matter and dark energy are, at least simplistically. Go ahead.
Okay. All right. I was just gonna say we also know that it's cold, quote unquote, rather than hot, which means I was just wondering, could it be cold but still be a modified form of Newtonian gravity?
I mean, yes. The thing with the cold part is that dark matter, if it is an actual matter, it does not contain a lot of thermal energy. It's a very cold form of matter, and that's what CDM stands for. If you ever hear a reference to what the Big Bang Theory really is called today, the lambda CDM model. The lambda represents cosmological constant, or the expansion of space-time, accelerated expansion of space-time as a result of dark energy, and CDM stands for cold dark matter.
Yep.
Like my cold dead hands.
Silence.
Well, immutable. The thing is that the decay of the inflaton field, or more appropriately, its phase transition from metastable state to true vacuum state, is what caused inflation. So that field is already decayed into the traditional standard model particles that we see today. So the inflaton field doesn't really have anything to do with the way that the universe is structured now, or its expansion or potential accelerated expansion.
So for the boys and girls out there, this book is very good. He says at the end, for one thing, he said Schrodinger came to some absurd conclusions about time and entropy and life. He said it makes no sense to apply the idea of entropy to living systems. And he lists, I think, 20 popular definitions in dictionaries for entropy. And then he states these are all wrong. They're all incorrect. So he goes through it in some detail, and it's a very approachable book. It's for kids and their curious parents. So,
alrighty,
anyway.
guys, I am going to take off.
All right.
I'll be
See you
back later
Thanks
tonight.
for
I don't
adding
know
to
if
the conversation.
yeah, no problem. I don't know if Speed, if you've got any programs coming on tonight, but if you do, I should be able to tune in. I can't
We
imagine I'll
have
be out too late.
we're supposed to do a paper at 7 p.m. So,
Paper trails?
yeah, but it may be later. I'm not entirely sure.
That's fine. I probably won't be back home until closer to 8, somewhere between 8 and 9 CST. So, well, me and you are in the same zone.
I'm
Speed.
hoping Immutable can come into the back stream here and discuss before we go undead.
Yeah, yeah, that'd be nice. Alrighty, guys, I'm out of here. Take care. Be well.
Thanks, Leo. Thank you.
See you. Oh, he's already gone.
Okay.
Thanks for letting Leo come in, Speedy. I think he definitely added to the conversation more than I could.
Yeah. This this book might be it's a really good place to start. In back, he goes on about how some of all the misconceptions about entropy, and he also talks about his own religious upbringing and how entropy is frequently used by religious people to say really silly things that don't make any sense. He also says that the arrow of time doesn't make any sense for entropy. That entropy is not about time. It's mostly about
true.
It's about statistics.
Right.
And the arrow of time thing came from, he traces it down to a couple of books. He said you got to be really careful with books because everybody assumes they know what entropy is because they read it from somebody who assumed they knew what entropy is because they read it from somebody else. And so he's claiming that few people truly understand the concept enough to be talking about it or writing about it.
Well, so the concept of entropy has gone through entropy.
Yes. Yeah. And even to say that would be a mistake according to him. So
the entropy of
entropy.
What variable should we call that? What variable should we give it? The entropy of entropy.
Entropy of entropy. Nonsense.
So maybe like an N with a big line through it.
A capital N, or else that Greek N-looking character. I forget what it's called. What is that Greek N-looking character? We could use that. So we could probably define it that way. But I guess suffice to say that creationists say a lot of really dumb shit.
Yeah.
For instance, Immutable pointed me at an article in Evolution News.
Oh boy.
Which talks about a recent paper, which is like really recent. I think it's like April of 2021, where they claim to have found a tRNA that replicates itself, or a version of tRNA that replicates itself. And then they go on and explain how ridiculous the article is. But the neat part about it is that it pointed us to an article, and it's very new, and it's called tRNA Sequences Can Assemble into a Replicator, which is kind of the, what the hell would you call it? I mean, that's a really important little piece, because tRNAs are very, very, they're not that big. What are they, about 20 nucleotides or something like that? Or they're very small. And they're the things that carry the amino acid and hook up to the codon and do the interpretation. So they are the code. So if they themselves, and there have been a number of clues that I've seen in recent papers about them having the ability to basically be enzymes themselves or ribozymes and be able to replicate themselves. So if they can replicate themselves, that would explain a lot of things. So, but these guys, of course, are going against it. We might do a little thing on that at some point because Immutable just brought it to me. I just started looking at it. And I'll be damned if I can find the paper. I think I'm going to reach out to the author and see if he'll send me a copy. I'm going to avoid paying $50 for it, so because I'm on a budget now. So anyway,
All right.
I thought I would throw that in at the end of your.
Speed, you're roboting for me.
Oh, really? Am I roboting for you, Scott?
No, you sound fine to me.
Oh, now you sound fine. Huh.
Okay.
Hey,
Yeah. I
David.
don't know. Every now and then stuff happens. Hi, David.
Hey,
So I
David.
think, should we go on dead with this stream?
Sure, that's all I kind of was going to talk about, unless David had something.
Yeah, David, you have something you wanted to talk about?
Yeah, well, I didn't want to change the subject, but yeah, it was kind of something interesting. I don't know, Speed, maybe you may not want to go over anything right now, but take a look at Sal's stream. I thought something was a little interesting with Danny, and you'd have to look at it to see if
you mean when
the interpretation. Yeah, go ahead.
Was that after I booted Danny out?
No, well, what happens? I watched some of Sal's stream from yesterday. You know, he had that after party stream, right? And Danny was on for a little bit, and he, of course, your stream, this stream always comes up, or your channel always comes up, and it's he who should not be mentioned. You know the old saying, same old, right? Well, Danny brought up something about well, there was a conversation. Remember, there was a little conversation, and Brenda came into a stream, and this was when was that? I'm trying to think if that was like yesterday, or the day before. And you guys were talking. I wasn't in the stream, but you guys, everybody was talking about Sal's credentials, and it just got brought up.
Oh yeah,
and then so Danny, you questioned it because I think you didn't know 100%. And it's interesting if you listen to Danny brought it up in Sal's stream. And it's kind of funny the way, because I would love to have had Danny here right now because I would ask him about it. But it was kind of like, I mean, you didn't know what his credentials were. Nobody, the way Danny described it in Sal's stream, he was like, oh, everybody was calling you stupid. You don't have any degrees. They were questioning your degrees and all. But like, I was watching that stream when that happened. I'm like, okay, I didn't get that impression. That's not what everybody meant. It's like they're all skewed. Like they don't. Yeah, I don't. You know what I mean? They're not listening. They're not listening. The same as what I'm hearing. Right?
Yeah, I've never questioned Sal's. I've never questioned his credentials so much as his reading comprehension.
What I was trying to figure out is how he could be so wrong about some of the things that he thinks, and so I decided that we should look into his credentials because he claims like I think the thing he said about Riemann's sequences yesterday or the other day was very surprising for somebody who has a handle on mathematics, right? That somehow free will changes the number that you're getting. When actually it is the way you define the sequence that changes the number you're getting, the number that it converges to. So there's that, but this was prior to that. This was me questioning his thing about why he thinks proteins evolved from a common ancestor, and I just couldn't imagine somebody who had gone to school for biology, evolutionary biology, whatever, think that or anything to do with biochemistry. And so I wanted to look into his degrees. I didn't mean this. I didn't mean to slam him in that way because the man has an applied physics degree that's pretty impressive, and he's done some impressive applied physics work.
Right, and
for NASA. So
right, and I think that's I think that's the view of everybody on this channel. But it's so funny that how they just have they don't comprehend the conversation. Like if you listen to them talking about this stream and talking about atheists themselves on some of the conversations, it's funny because I'll be like, okay, I was listening to the same thing that you're talking about, and I didn't hear anything of what you're saying. It's like they like you said, Scott, their comprehension skills, reading skills, or even comprehension on listening to an actual stream, like,
or just
really
thinking.
weird. Right. Yeah.
Well,
So that's what I mean. Like, that's what I'm saying about this. I mean, I don't think nobody was really saying anything bad about Sal's, credentials. It was more or less like you're saying, Speed, would just you disagree with, maybe his conclusions or his interpretation, whatever he was talking about, what you're saying, whatever theory or whatever he may have been talking about, you disagree with. Nobody's saying he's stupid or he doesn't have the credential. I don't know. So,
I think disagree is too light a word to use for what I think of Sal's conclusions. There's got to be a more powerful word than that. More like I find them to be pretty much nonsense. And the thing is, though, now Sal does a better job than James Tour. And James Tour is more highly credentialed and published than Sal is, right? But Sal at least gets some of it right, So I mean, there, it's hard to the degree game, and of course I'm famously a high school dropout myself. So, I mean,
Sal mentioned that.
Yeah, how could I question anybody's degrees? It's like, it depends on how good it depends on what your how much energy you put in to actually trying to figure this thing out. And Sal and I, he sent an email to me last night in response to an invitation to the stream yesterday. And he said to me, thanks for the advertising, but I think I'll stay out of your streams. And I sent an email back and I said, Sal, please tell me why you want to die on this hill of young earth creationism when you don't need it for your faith or your Christianity or anything about your belief at all. Because I know people that are have very deep faith in Christianity and Jesus and all of that, and they don't rely on any of this stuff at all. So why are these guys so obsessed with rewriting all of science and cramming it into 6,000 years? That shit about the Ice Age and that, the shit they do with, like with evolution, they can get away with it because they can snow the average listener enough to make them think that. Right. Yeah. But for God's sake, with Ice Age and with geologic formations, I don't think anybody with any common sense is going to buy that. Why do they want to die on this hill? And so if I'm questioning his credentials, it's like, how can an educated man think like this? It just doesn't make sense to me.
I feel the same way. Exactly. They have to deny or twist science or, pick it apart, cherry pick it, whatever, to be a young earth creationist. They have to do that. So it's crazy. And for somebody like you're saying with Sal's education, why would you want to die on that hill? Like I said, it's hard to comprehend. It really is.
And it has something to do with a reading of the Bible where if they don't literally accept certain things, then they think they have to abandon other things. Whereas a more faithful Christian would just say, you know what? There are some things we may not understand, but that's not going to get in the way of my faith, right? So there's
What's wrong with that? What's wrong with that? I know. Yeah, and it's crazy.
I think they lack faith. They lack faith in Christianity, so they want science to prove it for them. Sal has Lena has to say about Sal and his faith. Yeah, I don't think they have faith. They don't really get it.
I wonder if there are any studies that like look at people who want things to be neat and tidy, and if there's any correlation with that and pseudoscience.
It's interesting you bring up Danny. I booted him last night because I wanted to. I'd been silent for 10 minutes at a discussion, and when something come up about qualia and perception with Leo, I wanted to interject something which is a very difficult concept to understand, and it's called a shallow ontological view of qualia. Okay, and so I got the sentence about 90% out, and Danny says, you have nothing to offer to this discussion. So I banned Danny on all 5 accounts, and I will boot him from chat. And as far as I'm concerned, Danny's not welcome here anymore. And then he runs over there and he starts spewing. But now Danny is a person who is educated in philosophy and in sort of a particular vein of philosophy as it's taught in the West, I think. And I think a very, very naive and limited view of philosophy, where if you don't have an argument or like an analytical argument or a syllogism, or if your terms don't match that of traditional epistemology, Danny won't even listen to you. He doesn't even hear this. He doesn't even let you get the sentence out before he's coming back against you. Now, that is the same kind of rigidity in belief, I think, that these Christians have. And lo and behold, Danny was a Christian not long ago. And I think, and people can sound really fucking intelligent and not make any sense at all. And I've run some of the Danny stuff by a professional in the field, and a couple of people, and they pretty much concur with me. And I just don't think Danny adds anything to the channel other than confusion. So for the time being, Danny's out. So he won't have anything to run a report anymore over to his Christian buddies over there. Now that's a little vindictive and a little resentful of me, and I will work on that. But that's currently what I'm thinking. So I was going to let him back in today, but I slept on it, and I thought, hey, if you sleep on this, you'll see it differently in the morning. Yeah, I saw it.
And you didn't, so right? Yeah.
Well, no, I saw my position got more stubborn. So,
right. Yeah. Well, hey, that's your prerogative.
Yeah. The thing is, if I can't express my views on my own channel, what the hell am I doing here?
Right.
It's just like, I don't need this shit, guys. Don't do this to me. Don't think you're going to be able to do this to me. Anyway. So that's why Danny went in hot on because he was really pissed because I banned all 5 of his accounts. He kept coming backstage, back another. He had 5 sock accounts, for Christ's sake.
Wow.
Who has 5 soccer accounts?
I mean, Angelo, I think.
Why do you need that many soccer? I mean, I've got a personal account and I've got my channel account, and I had to create another account so I came up as Speed of Sound. So I have 3 accounts, and I have a business account.
And using different accounts to get into the Discords, which is the same account as you get into here, right?
Yeah, and that's fraud. That's fraudulent coming in as somebody else. I mean, I can see doing it if you want to go and if you're banned from somewhere and you want to go get some information or do a little mild trolling, I suppose it might be okay to do it, but for the most part, I just don't think you need 5 accounts.
Speed.
I was getting
Danny. Danny is a young, wild, free spirit. You can't tame him. I agree.
Can't tame Danny now. No, but well, I did tame him. He's not here.
A lot of robot, and I think it's me. Can you? I'm going to jump out and jump back in real quick.
Okay.
Okay. Because I think it's me.
David, we're going to go undead now. Okay. So I hope I've explained my Danny position to the people that subscribe to me, and I'm probably going to lose a few subs over it, but fuck it, this channel is more about genetics and molecular biology anyway. So we're going undead, guys. You want to say goodbye?
Keep being curious, everyone.
Goodbye, Stephanie. Goodbye, Benghazi.
Goodbye, Stephanie. We love you. We love you, Lena.
I love you,
love you, Benghazi. We love all you. Going undead. Goodbye, cruel world.